right, so now let's take a look at our last lesson on geometric series. So just like arithmetic series, we saw that it's the same thing as a sequence, but you're going to add your terms together. Same thing for a geometric series. So it can be found by adding all your terms together. We are going to have to remember a couple of things. So one is this formula, Tn equals a r to the n minus 1. And of course, a is your first term and r is your common ratio. So like, what are we multiplying by each time to get to the next term? Tn, of course, is our term that we're looking for, or our last term, and then n represents the number of terms. Now that was for a geometric sequence. So let me just write that down. This was our geometric sequence. Now what we're looking for are series, and there's only one formula that we're going to use. Sn equals a bracket r to the n minus 1. So that is not minus 1 from the n. You actually figure out your r to the n, and then you subtract 1 from there, all divided by r minus 1. So let's take a look at just a couple of examples on how this works. Determine the sum of the first 10 terms in this series. So let's start by writing out what we know. And what we know is a is 4. And I can see that r in this case is going to be 3. We're multiplying by 3 each time. And we want to add up the first 10 terms. So n is going to be 10. So Sn equals, so we're going to need our formula. So just let me go back just to make sure I have it. Yep. A r to the n minus 1 all over r minus 1. Okay, so a is 4, r is 3, n is 10, minus 1 all over 3 minus 1. Okay, so let's work this out in the calculator. 3 to the exponent 10 is where I'm going to begin. So 3 to the exponent 10 is 59,049. And then I'm going to subtract 1 from that. But just to show all my steps here, 049 minus 1 all over 3 minus 1, which is 2. So I'm going to subtract 1 from that and then times it by 4 and divide by 2. And I get 118,096. So you're probably thinking, like, how does it get that big? What are we doing? But if you think about this, like, we're multiplying, right? So we're multiplying by 3 each time, then it's basically tripling, which is an exponential. And just like exponential functions, we know they can grow rather fast. So we had 4, then 12, then 36. So if I times 36 by 3, my next number is 108. Times that by 3, I'm at 324. Times that by 3, I'm at 972. Already I'm almost at 1,000. Times that by 3, I'm almost at 3,000. Times that by 3, I'm almost at 9,000. So as we can tell, these grow very quickly. So if you get a large number, don't necessarily be surprised by that, because of course, when you're multiplying by a common ratio, it's actually an exponential function. Okay, how about here? Determine the sum of the series. So what do we know? We know a is 1, and I can tell that r is 2. I'm multiplying by 2 each time. I know my last term, Tn, is 512, but unfortunately I'm missing n. So I'm actually going to go back to my explicit formula, back to my geometric sequence formula, and put in my information that I know. And what I end up with is 512 equals 2 to the n minus 1, because that 1 doesn't do anything. Okay, so I want to change this 512 into 2 to an exponent. So I got to figure out how many 2's do I need to multiply by itself to get to 512. So I know 3 gives me 8, 4 gives me 16, 32, 64, 128, 256, 512. So I'm thinking 1, 2, 3, 4, 5, 6, 7. I'm thinking like around 9. Let me just double check that. Nope. 2 to the exponent 9. Yep, is 512. Okay, so now remember, solving equations is all about left side equaling right side, and I have my bases are the same, so I can just put my exponents equal to each other and add 1 and add 1. So n is actually equal to 10. Okay, so this means we want to add up the first 10 terms. So I'm going to use my formula Sn equals a r to the n minus 1 all over r minus 1. So the sum of the first 10 terms is going to be 1 times 2 to the 10 minus 1 all over 2 minus 1. 1 times 2 to the 10. So 2 to the 10 is 1,024 minus 1 all over 2 minus 1, which is 1, equals 1,023 times 1 divided by 1, so 1,023. So there we go. All right, so we had to go back and use our geometric sequence formula to find out how many terms we were talking about, and then add them all up. And there you go. So that's it. I know this one's really short and sweet. There's not a lot to it, right? So that brings us to the end of arithmetic and geometric series.